we would really like to thank you all for coming today, for having come all these other days. And Professor Martin-Delgado, once again, the faculty, the university, we really hope that this talk has, in some sense, helped you or been interesting or intriguing, that this approach to metabiology has been useful for you as it has been useful to us. Thank you very much.
So, are there questions? Any questions from the audience? I have one question that you mentioned in the last part. In the model of with the mathematical model, it is easy to implement. I mean, easy. It is feasible to implement random mutations, but is it difficult? It's really difficult to bring the environment interaction of the organism, software organism with the environment. It's really difficult.
So far, you know, the mathematician in the team, the lead mathematician is Professor Chaitin. So far, he hasn't seen it. But he has been working with one of his PhD students in Brazil, in the Federal University in Rio de Janeiro, and this is sort of the following. This would be the following step in the mathematical model, to try to bring this interaction, or at least bring a population, more than one organism at the same time. Right. Yes.
But at least. So is there a mathematical...
Yes, that's a mathematical feature. We do not know, because this is, you know, metabiology is really on its course, it's really starting. It is a paradigm shift. Really, it's not just talk. We really don't know in which direction and what will do well and what will do faster. We do initially have the inclination of starting with mathematical proofs, but we can also maybe get results from just simulating. So if we make little differences in the mathematical direction, in the sense that we start to simulate based on the mathematical model that has only one organism, but we find a way out to simulate based on this mathematical model with one organism, we find a way out to simulate many organisms, maybe that will give us a hint. We don't know yet. We haven't gotten to that point yet.
What you mean is that with algorithmic information theory, you can create random mutation. But if you want to bring the environment, interested with the environment, probably you need something else, something which is not in the algorithmic information theory.
That I pass on to Greg, definitely.
Okay, one thing that is easy to these models is symbiosis, which Margolis has shown us is very important. What you have is a mutation that takes two organisms as input and produces another organism as output. I thought this was sex, but it's actually symbiosis, because sex throws away half the genome of each of the two organisms going in, where symbiosis keeps the whole thing. Now, the environment I don't know how to model, but I can tell you one thing. Let's say the organism gets to pick itself the mutation. Rather than being subjected to a random mutation, I am an organism, and I can calculate a mutation to be that you're going to try to apply to me to see if it gets a fitter organism or not. If you take that and put it in the models, then unfortunately what you get is intelligent design, which is too bad, because then you can actually have the organism remember, I think, have enough memory to systematically try all the mutations. Is that true? I'm not sure if that works. It looks like it would go in that direction at any rate. Maybe not quite, because you would get stuck actually. It looks like it's going to work too well, is my feeling.
Intuitively, it should go the other way around. I mean, instead of having something which is quadratic or cubic, it should go with a different scaling law, but it would be something which is a scaling law with a different exponent. That would be the best.
Well, look, just remember, take an organism and just have it have memory. Have it just remember one number. If you can add one number to the organism as memory, you can use that to remember, did I try this mutation M sub 1, did I try M sub 2, did I try M sub 3, did I try M sub 4? And so what the mutation is doing is it is going to call for trying exactly the
The
mutations
mutation that takes you a step.
that gives you one more bit of omega each time you try a mutation, which is going to be very fast. So that is a little discouraging, because it suggests that if I try to have mutations instead of being random, some intelligence involved in trying out mutations, then the model collapses and I just get the fastest possible rate of evolution, which is not too helpful. So it's you know, that when you're, this is really the model, shall we say, is a little how should I put it, fragile at this moment. That almost any attempt to add a new feature to it makes the whole thing break down. So in other words, this is a serious research project. Basically there's just one or two examples, and it's not at all clear to me how to add environment, how to add sex, how to add populations. All of this will take creativity. Another possibility is most people in this who work on models of evolution like to do computer models and see what happens when you run them on the computer. You know, these little toy creatures in this toy environment, and maybe Metabiology can suggest to them adding something to their models and maybe putting a computer software in these little organisms, and trying, you know, you can take one of these models with an environment and organisms that can move around or eat each other or something, and you can put inside a control mechanism now, which is a program, an algorithm, and you can try doing random mutations on those algorithms. So this would be sort of a way to combine at least one idea from metabiology with the whole scenario, the sort of more realistic, animalistic scenario of a computer model of evolution, which does have an environment and creatures that have some capabilities like mobility, eating each other, a finite lifetime, having the need to eat food. So there might be ways to sort of take that traditional approach and combine it with at least one basic idea from this approach. So the answer is I don't know, and it's only been, you know, 2 of us for 3 years. So please, we welcome, if these ideas are all stimulating to you, please help yourself, go ahead. You know, use them in your research if you think that any idea from here is helpful to you, or if you want to jump in and try to prove theorems in these kinds of formal models, that's fine too. We're going around giving talks on this in the hope that maybe other people will get involved in some way or another, and we can see if these ideas go anywhere or not. You know, and we don't know in which direction they may go and which directions may not work. So that's sort of the state of the status of the thing at this point.
Yeah, one question.
There's not a question really.
Comment.
I think,
Comment?
Question or comments?
Okay. I think your work about creativity, really is so interesting. But I think it lacks the correct behavior. I think that the creativity it's okay, but what your model lacks is when and how this creativity arises in a elapsed time. I think en un periodo de tiempo. I think that this creativity is it's okay. It can be the model that you propose can be a powerful model, but what I really think that Maximus and in theory, or we are working now about simulation, can apport to the model is that this behavior that biological systems have to react to the environment properties, and changes the time and the rate that the creativity arises. I think that the creativity could be accord with your proposition, but the time and the behavior is what you model to my opinion.
Of course.
I think that lacks, no?
Yeah, so you don't get punctuated equilibrium, for example.
Yeah.
But so Maximo's models, randomness, it does not play an important role in Maximo's thinking. It's more that evolution is a response of the biosphere to changes in the environment, for example. There's more intelligence in the system.
Yeah.
In other words, these viruses that drive evolution forward by spreading genes horizontally, they're not random viruses. They are.
Yeah.
There's no randomness. Does not play a major role in that theory. Remember that Virginia talked about two different ways of thinking about the.
Yeah.
Yeah. Where would Maximus Sandin be, if I could make a question?
I think that Maximus thinking is nearly is more.
Should we say Lamarckian? And
It's more Lamarckian and more similar to Margulis' thinking.
Okay.
But I think that Maximo proposition is in another level of thinking because the integration of the virus integration, also another mechanics.